on the projector. Okay. Okay, and we'll start from current slide, but we won't start there yet. Well, not starting from current slide. There we go. Now, a couple of announcements. Do you have any Friday classes? No. Okay. Won't make a lot of difference to you then, probably. But my office hours for the rest of the week are pretty much normal. Today I'm 1:15 to 3:15, just like I am most Tuesdays and Thursdays, and that'll be the same on Thursday. Okay. Darius is here, and Anil is here. Okay. Tomorrow will be my regular office hours, as far as I know, from 3:15 to 5:15. But not Thursday. I mean Friday, okay? Friday, the college is closed. We are celebrating Veterans Day. Actually, Veterans Day is Saturday, but they're giving us Friday off. So don't come looking for any advisor, any instructor, any help, any tutoring, anything else. Everybody will be home, okay? The college will be closed on Friday, okay? Now, next things. I think I may have mentioned this before, but I wanted to be sure I say it again. I forgot it in my morning class, so let me say it first class. Let me say it now. Mr. Racy is the math team coach, and she is looking for people who might want to participate next year. This is the time to start preparing for math team for next October, not September. That's what we've always, well, the 2 years we've done it. We just got started last year, and we just got started in September, so we did. And then we didn't do anything until this September and did it again. And we did okay, but we didn't do nearly as well as we should have done. So she wants to start practicing for it now, okay? So if any one of you or anyone you know is going to be here next fall and wants to participate in math team, please consider it. Y'all are good math students. You are the cream of the crop, okay? You are our best prospects. And guess what else? It's going to help you in your future courses. Because the stuff you'll be practicing on now, we're going to be showing you tricks and things like this that we don't usually do in class because there's not time to how to do these things quickly, efficiently, and smartly, and get the things done. And you'll be doing calculus stuff before you ever get to calculus. And it will really be, and it's fun. Everyone who's participated in it has really enjoyed it. So don't write it off, oh, I don't want to do any more math. I think you'll find math is, doing this will be both fun, enjoyable, and rewarding. So please consider being the math team. And there's something else I'd like you to consider. I'm guessing all of you are greater than 18, right? Okay. Now, I don't know if all of you are eligible to vote in the U.S. Are you? So, you are? Fantastic. Okay. Are you registered to vote in the U.S., in the state of Alabama? Yay or nay? Are you registered?
Yes.
All right. If you're registered, do you know there's an election coming up in December? Fantastic. Please do not forget to vote on December 12th. It's our senatorial election. It's an off election. It's not with any other elections. There's just one office there. Don't minimize that. Don't think, oh, that's not important. It's only one thing. It's not worth my time. It is worth your time. Please vote on December 12th. Okay? I'm not going to tell you who to vote for, how to vote, anything like that. I want you to get into the habit of voting every time the polls are open. My wife did some figuring. She's worked in numbers a lot. She looked at the leading candidate on the ballot in the primaries got 8% of the registered voters in the state of Alabama. 8, and he won his primary with 8% of the registered voters because nobody voted, very few voted. Does that sound like a democracy to you? I think not. Okay? If 8% is deciding who our next senator is going to be, that's a small group of people they're committed to getting out to vote, and the rest of us are apathetic and not voting. We get what they want us to have, not who we want. So please, folks, get out there and vote. Get your friends to vote. Get your families to vote. Get everyone out there that you can. Do not miss a vote if you ever can help it. Now, I know this is off year. This makes your vote even more important, because the off year, when the presidents aren't running and that kind of stuff, the voter turnout is really low. This one's going to be probably pathetically low. The more of you get out and vote, the bigger your voice is, the stronger your voice is. Please vote. I'm just harping on voting on December 12th. Please do it. You're registered? Huh? To register to vote in the state of Alabama. Yeah, and you're going to vote on December 12th, right? I'm not going to tell you who. It's the Senate election. Remember? Yeah, don't forget to vote on December 12th. Okay? That's the only team running, the only match of the thing. It's worth it. Go. Vote. Either on your way in or your way home, vote. Don't forget. Okay. Brittany's here. All right. That was paid political advertisement. Okay, never mind. No, I'm not telling you who to vote for. I'm just saying vote. Be sure to vote. All right. Now, if I'm not mistaken, okay, let's say where we are. And by the way, this is a good time to reminisce a little bit. Research papers. This class has been pretty good about getting papers in, but I haven't seen many for a while, and now I'm guessing about more than half the class, I think, is not turned in a paper. So folks, we're running out of term. Don't put it off till the end. Get your papers in. Number 2, the first test. One person has not turned this in. Now, I don't know if she's going to continue in the course or not. She hasn't been here in quite a while, so I'm guessing she's not. But until I see that she's withdrawn, I can't return those. But you certainly can see your scores if you need to. Okay, second test. 5 people have turned in the second test. And we're coming close, folks, to having the third test. So please don't get too far behind in the test either. And as soon as I hear about that one other student, then I will know. Hilsa is here. Just a reminder for people who just came in, the college is closed this Friday. Okay? It's the day we're celebrating Veterans Day. Veterans Day is actually Saturday, but we're having Friday off for Veterans Day. So don't go on the campus on Friday. Okay. So, we're in Chapter 5, Analytic Trigonometry. We're in Section 5.4, which is Sum and Difference Formulas. Okay? We had done Example 1, and we're ready to start Example 2. Before we get started on it, any questions on anything we've done so far? Okay? If not, here's Example 2. Find the exact value of cosine of 75 degrees. Now, when they say exact values, what do they mean? Second? Okay, this will be in degrees, so it's not radians.
They mean the one where you subtract.
What's that?
You see, you can subtract the.
Right. Well, what they're meaning by it, leave the term, if you've got it, excuse me. If you've got the term of pi in there, leave it in there. Don't multiply on your calculator and come up and round it to 3 digits or 2 digits or 5 digits or 15 digits. Those are not exact answers. Those are round-off answers. If you leave the pi in there, typically you're going to have an exact answer, okay, or something else, okay, radicals, whatever, okay. You won't have pi in this one because it's in degrees. But so let's do cosine of 75. Now, as Ilsa, I think, was suggesting, we're going to use the ones we know exactly. And what are some of those that we know exactly? What are the angles? We know 0, of course. We know what was the next one? 30. Yeah, 30 degrees, since we're in degrees. 45. Say again? 60. And 90. Okay. Now, we know what the cosine of each of, well, I won't get into that yet. Okay. Now, obviously, 75 degrees is not one of those we know exactly, right? But is it a combination of two of those that we do know exactly? What would it be? All right, so cosine of 75 degrees is exactly the same as the cosine of 45 degrees plus 30 degrees. Is that how you said it? Or 30 plus? It doesn't really matter how you do it. Okay, now, what we've got to do now is come up with the sum formula. Does anyone remember how that went for cosine? Okay, so cosine 45 times cosine of 30. What next? Minus sine of 45 times sine of 30. Okay, I've almost run out of space there. Okay, so let's back off a little here and get it. Anyone remember what cosine of 45 degrees is? Square root of 2 over 2 times what the cosine of 30 is. Square root of 3 over 2. Okay, minus what's the sine of 45? Square root of 2 over 2. And what's the sine of 30? 1/2. Excuse me. Okay? When we multiply those together, what does the numerator of the first term become? Square root of 6 over 2 times 2 is 4 minus square root of 2 over 4, which you can write over the least common denominator, root 6 minus root 2 over 4. There's your answer. Okay? And that's exactly what they get in the text as well. Does that make sense? Remember how to do it? The sum and the difference formula is what you use here. Now, if my memory's not wrong, let me just make sure. The next one they do is 5. That's what I was thinking. So let's back off and do example 3. Okay, this time I'm going to erase. Let me just, it's so much easier to just erase it all. All right. Then I'll write back what I need. Okay. Find the exact value of sine of u plus v. Okay. Given that the sine of u is equal to 4 over 5. Okay? And Terrell is here. All right. We're on page 376, chapter 5, analytic trigonometry, 5.4, sum and difference formulas, example 3, just about the middle of page 376. Okay? Given that sine of u is 4.5, is 4 over 5, where also 0 is less than or equal to, no, is less than u, and u is less than pi halves. Now what is that telling you? Where is u? Or where are you? No. If you're between zero, here in the first quadrant for u. Doesn't tell us anything about v, okay? Here's what else they tell us. They tell us that cosine of v is equal to negative 12/13. Okay? Now what does that tell you? It's sort of a negative thing. It tells you that cosine, that v is not in the first quadrant. Why can I say that? Why can I guarantee you that v is not in the first quadrant? Yeah, everything's positive in the first quadrant, and since cosine is negative, v is negative, v can't be in the first quadrant. It may be in which quadrant? Which of two? Second or third, exactly. Second or third quadrant. It can't be in first or fourth. So cosine's positive there. Okay, just a little bit of stuff, what we know. Oh, but here they tell us. They tell us that pi halves is less than v, and v is less than pi. Okay, so they told us. Which quadrant is that? Second, yeah, and cosine's negative there, that makes sense. Okay, so it says find the exact value of sine of u plus v. What is the sine of u plus v? Remember that one? What is sine of u plus v? Some angle formula. Sine of? Say again? Okay, I'm going to write u, okay, times cosine v minus sine, say again, sine of v, okay, that's fine, cosine of u, okay, that's fine, okay. Now, we know this one, we know that one. Do we know what sine of v is? Say again? Oh, but did we get it? Okay, how? Draw a triangle, exactly. And your triangle doesn't have to be dimensionally correct, but we know it's over here in the second quadrant, so I'll draw it over here somewhere, and I'll draw it like this, okay? Whoops. All right. We'll say that v is this angle here. That's v. We know it's in second quadrant somewhere there. And we know that, what is cosine v anyway? What's the relationships there? Cosine is adjacent over hypotenuse, and that would be your x, which happens to be negative here. So we'll call that minus 12, and your hypotenuse must be then 13, because hypotenuse is always positive, no matter which quadrant it's in. Hypotenuse is always positive. We often call that r too, if you want to. X over r. Adjacent over hypotenuse. Okay. Now, mine probably isn't correct there dimensionally, but it's okay. Now, from that, do we have any idea what sine of v is? Yes, we can use Pythagorean theorem. And how does it go? Okay. Which one do you want to be a squared? Minus 12 or the unknown? All right. Here is. I'll find you in a minute. Here, right. All right. Say it again now. The unknown will be a squared, so that would be, you want to call it a then? Okay. A squared plus, second, what is your b here? Is that 12, yeah, you see is your hypotenuse. So that, what would b squared be then? 144 is equal to 169. Very good. So how do we get what a squared is? Subtract 144 from 169. And that would give you 25. If a squared is 25, what must be a be? It could be plus or minus 5. But since we're in the second quadrant, we know it's positive, so this is equal to 5. So what is sine of v then? 5/13. We now know it. Okay? We need to do the same type of thing with u. Okay? With u, okay. What color you want to do u? Same color? Okay. We'll keep it there. Okay? So u is somewhere here in the first quadrant. I'll draw it here and make that being u. Okay? And what did we know about it? All right, let me get Chelsea. Yeah, Chelsea is here. Okay. So the opposite side is what? 4. Hypotenuse is 5. That leaves the adjacent side being 3. The 3, 4, 5 triangle, my dad's favorite. Okay. We used to do buildings and stuff like that, and that's how he found out if he had right angles. Okay. So cosine would be 3/5. We know them all then. So sine of u, they told us, was 4/5 times the cosine of v, they told us, was -12/13. Okay? Minus, wait, did you tell me that right? What the sine u cosine v, did someone say minus sine v cosine u? If it's a plus here, it's a plus there, right? Yeah, cosine is negative, plus minus, sine is plus plus, or minus minus. Cosine is minus plus or plus minus. Okay? How about sine v? What did we say that was? 5/13. And what is cosine u? You just told me a little bit ago. 3/5. Okay? Now, good news is we got the same denominators again. Okay? And 13 times 5 is 65. So that's going to be your denominator. Your numerator on the first term is -48, right? And on the second one is +15. So what does that add to? -33/65. And I don't think there are any common factors between those two. Oh, Chaston decided to come today. And Whitney as well. All right. Anybody else come in since we called roll? Now, for people who have just come in, let me remind you of this. I've said it a few times now, but you might not go back and listen to it. I hope everybody knows it's really sad news. The college is closed on Friday. So get over it. We have Veterans Day coming up on Saturday, so the state of Alabama is big on celebrating Veterans Day, which I appreciate, okay? But so we are having Friday off. So don't plan to come see an instructor, an administrator, a business office, or anything else. College will be closed on Friday. I will not be on the Birmingham campus from 7:45 to 11:45. Not. I'll be on the road to Georgia. Okay. All right. So we got -33/65. No common factors there. So that's done. All right. Any questions on that? That was example 3 on page 376, chapter 5, analytic trigonometry 5.4, sum and difference formulas. So let's go on to example 4, which is also not on the slide set. So if everybody got everything they need here, let's do example 4. Okay. Write this, okay? The cosine of the arctangent of 1 plus the arc cosine of x and by the way, I didn't say it, but every time it's true, every example they have in the text, there is a checkpoint which you can go home and do, go to the library and do, go to another classroom and do. As soon as you can, try to do those checkpoints while what we've done in class is fresh on your mind. Okay? So write that thing as an algebraic expression. Okay. Now, someone remind me what we mean by an arctangent anyway. It's what? It's an inverse tangent. That's exactly true. What does that mean? It means that Justin's speaking. Okay? What do we mean by arctangent of 1? What does that mean? It's what? It's what?
I said it would be a negative 1 for 10. I said it would be a negative 1 for 10 when you.
Okay, yeah, if you said arctangent, if you wrote an inverse tangent, it would be tangent to the minus 1 of 1. Yeah. Those mean the same thing. Arc and tan inverse minus 1, those mean the same thing. Okay. Now, but what does that mean to us? What is an arctangent? Second? Yeah, not the reciprocal. Okay? That's 1 over. It's the inverse. Now, okay, let's start this way. When we're doing a trig function, and what follows a trig function? Sine of something. What does that pi third represent? An angle. And you get a number, right? You take a trig function of an angle and you get a number, right? So when you're doing an inverse trig function, you're doing that of a number, and your answer is the angle. So this is an angle. And that's an angle. They're inverse trig functions. And this is a cosine of the sum of 2 angles, right? Is that right? All right. Now, before we proceed with that, let's name those angles, okay? The angle, okay. Someone tell me what arctangent or inverse tangent of 1, another way to write that. Let's name this angle. What you want to name it? Fred, Susie? No, I'm sorry, not that. Okay? Okay, throw your calculator around. See if I care, okay? What is a good name for an angle? Theta. I like theta, okay? Let that be theta. Give me a different one for this angle. Delta. Okay, deltas look something like that, I think, don't they? A small delta. Yeah, that's capital delta. This is small. I did a small theta. Well, you can't tell it's small. But, so you would rather have a delta, and that'll be a capital theta. Capital theta looks a lot like a small theta. So, okay, whatever. Okay. This is really ugly looking now. Okay, so that'll be your delta. Okay. Okay. Now, can someone write, okay, what this is saying, what you just told me, is that theta is equal to the arctangent, I can't write, of 1, and delta is equal to the arc cosine of x. Okay? So I want you to write this expression in an equivalent form, but not using an inverse tangent or arctangent, using a tangent. an equivalent equation to this, but don't use an inverse tangent or arc tangent. Use tangent. What's an equivalent equation? Says the same thing, but without the inverse in it. It says that, no, that tangent of theta is equal to 1, right? If the arctangent of 1 is equal to theta, that means the tangent of theta is equal to 1. You take trig functions of angles to give numbers, you take inverse trig functions of numbers to get angles, right? So you just flip that around. That means the arctangent of theta is equal to 1, right? Isn't that an equivalent statement? I take it you think not. Okay. If this is an angle, that's that number, that angle. What do we do with angles? We take trig functions of angles. We take the tangent of theta, that gives you that number 1. Those are equivalent statements. An inverse function undoes the other function. So if the arctangent undoes the tangent, then the tangent undoes the arctangent, right? So that's it. Do the next one for me. Cosine of delta is equal to x. Agreed? Yay or nay? Okay. Got it? All right. Now, what I want you to do then is using your sum formula. Oh, and by the way, does anyone tell me what theta is? What angle theta, when you take the tangent of it, do you get 1? Okay, that or pi fourths. Most of the time we'll stay with radians. Let's see what the book does. I've got to find it in the book. Okay. They don't even say it this way, but that's what it is. Okay? Now, can someone, using the cosine of a sum formula, because that was a sum, right? Tell me what that would be. Shouldn't that be? What's that? I can't hear. We need sine? Okay, not necessarily. Let's just write down what that is. We can leave it in thetas and deltas, or you could leave it in arcs and arcs, you know, but what is the cosine formula? It's cosine of a sum. Wouldn't that be cosine of theta, cosine delta, minus sine theta, sine theta delta, right? Running out of room there, right? But we know what theta is, pi fourths, right? So the cosine of pi fourths is what? Square root of 2 over 2. Okay? And then the cosine of delta. Well, wait, what is delta? This would be the cosine of the arc cosine of x. And what happens if you do a function in its inverse function? What do you wind up with? Not 1, whatever the argument is. X. One undoes the other. So this will be square root of 2 over 2 plus x, no, times x, sorry. Yeah, my eraser's not erasing. There we go. That would be times x minus, now we need that. Well, wait, what sine of theta? If theta is pi fourths, what would that be? Square root of 2 over 2 Oh, but now we need the sign of delta. You're right, we do need that sign. Okay, I don't think for the same reason you were talking about, but what would that mean? If you know that cosine delta is equal to x, what will you do? Draw a triangle. Okay, it doesn't have to be a very pretty triangle, just any old triangle will do. If you know that cosine delta, let's call this delta, is equal to x, what is that? I need a ratio there. What ratio would that be? X over 1. That makes what the x? The horizontal leg, the x, and the 1 is your hypotenuse. So can you tell me what the sine of delta would be then? That's what we're looking for here, sine of delta. Second? Okay. The square root of, is it that, or 1 minus, what'd you say? Not x, squared. Because it's this, Pythagorean theorem says that this squared plus this squared is equal to that squared, right? So this squared minus this squared is equal to that squared. So then take the square root of it and do 1 minus that square root of 1 minus that square. Right? So there's your, so now that we know that side, what is your sine delta? The square root of 1 minus x squared. Yeah, and you don't have to put it over 1 if you don't want to. All right, so in this case, we can factor out the square root of 2 over 2, and that will leave us with, yeah, x minus the square root. My pen is so slow. 1 minus x squared. And there we have expressed the cosine of a sum of inverse trig functions as a expression in x. Let's see if it's the same thing they got. Yeah, they said square root of 2 over 2 is the same as 1 over root 2, which most of the time we don't do, but if you did that, then that just puts that difference there over root 2. So, yeah, that's how they did it. Either answer is right. Now, if you were doing WebAssign or some of those homework packages, nope, you got to keep working at it until you give them the answer they want to see, because they only recognize one correct answer. Whereas both of those were perfectly correct, but if you had written down the one they weren't looking for, they tell you it was the wrong answer when it really wasn't wrong. It was the correct answer, and you think you did something wrong. No, you didn't. You just didn't have it in the same form they were looking for. So one reason I kind of don't like those automated packages like that. I spend more of my time trying to explain to students how, no, you got it right. They just we're looking for a different form of the answer. And then having to adjust grades and all that kind of stuff, it really makes it a pain in the neck. And by the way, though, I did ask the book rep to set up these things for me. So WebAssign is out there for you. You were sent an email, and it's on Blackboard somewhere under announcements, I think, that what your code is, that you can enter the access code, and you can use all those tools. WebAssign does have great tutorials and explanations and stuff like that. So by all means, use that. You paid for it. When you got your book, so use it. But I just don't use it to do homework because it's a pain in the neck for me, and I think for y'all sometimes as well. Okay, let's move on. That's enough of my crying about WebAssign. Okay. All right. Example 5 is proving a cofunction identity. Okay, now, actually, well, They have a nice little blurb in the margin of your book there, the inside margin, about Hipparchus, considered the most eminent of the Greek astronomers, born about 190 years before the birth of Christ, BC, in Nicaea, which was, I think, in Asia Minor. I'm not sure, but I believe so. He is credited, maybe as one of the islands of Greece. No, I think it may be a city in Greece. Okay? He is credited with the invention of trigonometry. Yay! Hipparchus, okay? Also derived the sum and the difference formulas for sine plus or minus A plus or minus B, and cosine plus or minus B. A plus or minus B. So, he's responsible for this, folks. The whole course, and especially this section. Okay. So, he would be a potential paper topic. This cannot be your source. This can lead you to your source. This can give you your idea, but not be your source. All right. So use the difference formula to prove this cofunction identity. What is the sum of a difference? The cosine of a difference. That would be cosine pi halves times cosine of x plus sine of pi halves times the sine of x. Okay? Pretty ugly x. Okay? Supposedly that's equal to sine of x. Doesn't look very promising, does it? Okay? Now, what is cosine of pi halves? Zero. So if this one's 0, that whole term is 0. So this leaves us sine of pi halves. What's sine of pi halves? 1. 1 times sine x is equal to sine x. Sure enough, what they were telling us before was true, that cosine of pi halves minus x is the same as sine of x. The sine of a complementary angle is the cofunction of that angle. Okay. The cosine of the complement of an angle, x, would be the cofunction sine of that angle, x. Okay. And we just proved it. There is also a checkpoint there, which is well worth your time to do. All right. Let me erase this. And we'll see how they did it. Using the formula cosine u minus v, we have that cosine of pi minus x is pi halves minus x is cosine of pi halves cosine x plus sine of pi halves sine x. Cosine of pi halves is 0, sine of pi halves is 1, so that leaves you just simply sine of x. And that's exactly what the right-hand side was. Okay. Sorry. Now, weird weather we're having. I feel like I've got a sore throat coming on. Sorry, I'm scratchy or gargly. So the sum and difference formulas can be used to rewrite expressions such as, remember when we've had our solution to be something plus n pi over 2 or n pi or 2n pi and something like that. Well, when you are evaluating things like that, then we can rewrite this sine of theta plus a n pi over 2 or cosine of theta plus n pi over 2. When an integer is expressed, n is an integer, these expressions involving only sines and cosines. The resulting formulas are called reduction formulas. So let's write both of those. What is sine of theta plus n pi over 2? What would that be? Say again? Sine of theta times cosine. The sine of a sum formula is sine cosine plus or minus cosine sine, right? So this will be sine theta cosine n pi over 2, with sine is same sign, plus cosine theta sine of n pi over 2. Okay? Now, let's start with the cosine of n pi over 2. If n is an integer, then these are your half pi's. That would be pi halves, 3 halves pi, 5 halves pi, 7 halves pi, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. Those are all your half pi's. What is the cosine of all those values? 0. Okay? So that first term is 0. Okay? The second term, these are your sines of those half pi's. Well, the sine of the half pi's are either plus 1 or minus 1. Okay? So, which one is which? With n is even, they're positive. If n is odd, no, that's not right. Yeah. Wait. If n is even, though, okay. Wait. I was not quite right on that. Because n, since it's over 2, that gives us a problem here. Because if n is even, that would then be not a half pi, but a whole pi. And then your cosine would be 1s or negative 1s. So, yuck. So they're not asking us to, I was just going to do this for you to show you what it is, but because n with any integer, depending on even or odd, it could be 0 or not 0, okay? So don't worry about that. I was jumping ahead, thinking I could do it without giving the specifics. Let's go to the specifics, okay? Like example, is this 7? No, they skipped 7, didn't they? They skipped 6. So let's go back and do 6. Okay, we'll do 6 here. Okay, simplify each expression. This is what we should be doing. Cosine of theta plus minus 3 halves pi. You only do these for specific values, not for a general value. Okay? What does your sum of the difference formula tell you? Cosine theta. Say again? Cosine of a sum or difference is cosine, cosine, sine, sine. Sine is sine, cosine, cosine, sine. Okay, so that would be cosine theta, what you say? Cosine of 3 halves pi. No, cosine is the opposite signs. So that would be plus. Sine's the same sign, cosine's opposite sign. So that's a minus, this becomes a plus. Okay? Sine theta cosine 3 pi over 2. Okay? No, sine. What are you having me write that for, huh? Okay. Sorry about that. Sine 3 pi over 2. Okay? Well, what is cosine 3 halves pi? 0. So this one's 0. And what is sine of 3 halves pi? Negative 1. So this will be negative sine theta. That's your reduction formula. So cosine of theta minus 3 halves pi is minus sine theta. Okay? And there it is. Yeah. They got it right too. Good for them. Let's do this one. Tangent of theta plus 3 pi. Does anyone remember the tangent of a sum formula? I take it not. Okay. What is it? Tangent theta. Say again? Plus tangent of 3 pi over 1 minus tangent theta over tangent of 3 pi. Okay? Now, what's that? Oh, yeah, you're right. It's multiplied. Sorry. Okay. God, the eraser's not working. Sorry. Product. Tangent theta times tangent of 3 pi. Okay. Yeah, that's... Yeah, product. Okay. Now, I was just going to say that gives us some problems because what if that denominator was 0, but it's not. So, all right. Anyone know what the tangent of 3 pi is? It's what? Okay. Second? 0. Why? Because the tangent of 0 is 0, and what's the period for tangent? Pi. So every whole pi is 0. So 3 pi is just the same as the other. So this would just be tangent theta over 1. So this is just tangent theta. Came out awfully simple, didn't it? Okay, tangent theta. Very good. There is a checkpoint there. Highly recommend you do those. Okay? Let's see. That was example 6. I think the next one they do is example 7. Okay. Here we go. Example 7. Find all solutions to this trigonometric equation. The sine of x plus pi fourths, they haven't written this well. Okay? This has a bracket after the pi fourths. Has a parentheses for pi fourths, but then a bracket after that. Plus the sine of x minus pi fourths, and they left off that bracket as well. See, they open a bracket, but they never close it. You got to do both, okay? Any of you do any computer programming? Get you in pretty serious trouble if you leave off the parentheses. Really serious trouble. Also, actually, using your calculators, you'll get wrong answers if you don't put parentheses where they belong as well. Okay, so this is the thing that's equal to -1 on the interval 0 to 2 pi. Okay? Now, where would you begin on something like that? Yes, use the sum and difference formula. And what would that be for sine? Sine of x times the cosine of pi fourths plus cosine x times the sine of pi force. Okay, that's the first one, plus, I should have started on the left-hand side, shouldn't I? Sine x cosine pi force minus the cosine x sine of pi force. Right? And supposedly this is equal to 1. Sorry about that. But what do you notice here? These two terms are exactly the same, but one positive and one negative. So they add to 0. All right? Don't have to do another thing with them. Okay? Now, these two are exactly the same with the same sign, but before we do it, what is cosine of pi force? Square root of 2 over 2. So this would be 2 times radical 2 times sine x, right? Okay, so 2 times radical 2 over 2 would be root 2 times the sine of x is equal to minus 1. I think that was a minus 1. Well, yeah, I left off the minus down here. Okay, and I think we could solve this, can't we? How would you go about solving that? No, I wouldn't. Say again? If it was added to sine x, I would. You do? Do what? Okay, no, I wouldn't do that either. Divide by radical 2. Yeah, they're multiplied, so undo it by dividing. Okay. The radical 2's go out, and that leaves you for sine x. What you're trying to do is solve for the trig function first, then we'll solve for the x. Okay? So we were trying to strip away everything around the trig function, get it by itself, and that's equal to negative 1 over root 2. Now, another way of writing that would be what? Negative. You multiply the numerator and denominator by root 2. Root 2 over 2. Okay? Does that ring a bell? Where is the sine? At what angle x is the sine negative root 2 over 2? 3 pi fourths? Is that right? Nope, don't think it's 3 pi fourths. So pi fourths is in the first quadrant. That's not negative. Nothing's negative in the first quadrant. 3/4 pi is over in the second quadrant. Some things are negative there, but not sine. So it would be 7 pi fourths over here, or okay, 1 pi fourths is positive, 3 pi fourths is positive, 7 pi fourths is negative. What are we missing? 1, 3, 7. 5/4. Okay. Okay, watch the patterns. They work in trig, okay? So x is either going to be 5 pi fourths or 7 pi fourths. See it? All they're asking for why is that not right? Okay? They're asking for all the ones between 0 and 2 pi. 7 pi fourths just short of 2 pi. So those are our two. Okay? Agreed? Let's see how they did it. Let's us erase all our slides here. And let's see how they proceed. They first do the sum formula, even though they left off their brackets, but they still did it right. Sine x and cosine of pi fourths plus cosine x sine pi fourths plus sine x cosine pi fourths minus cosine x sine pi fourths is equal to negative 1. Okay? Well, these two add to 0. These two make 2 of them. Okay? And then when you have that, 2 sine x cosine pi fourths, that's what we got there, is equal to -1. Cosine pi fourths is √2/2, and cosine, and then multiply that by 2, you just get √2. So √2, well, they multiplied it out. 2 sine x over times √2/2. The 2 in the numerator divides out the 2 in the denominator, leaving you √2 sine x equal -1. And then divide both sides by √2, you get sine x equals -1/√2, which you could write as -√2/2. And what 2 angles give that to you in the first quadrant, in the one time around the circle, between 0 and 2 pi? That'd be 5 pi-fourths and 7 pi-fourths, just like you found. That's the last slide. However, it's not the last example. All right, so let's do the last example. And they say this is an example from calculus. Verify this. The sine of x plus h minus the sine of x over h. They say that's equal to cosine x times the sine of h over h minus the sine of x times 1 minus cosine of h over h. Of course, they say h cannot equal 0. Of course, you can't divide by 0. Okay? So let's do that, but let's split this into 2 pieces. Okay? And do one piece with the sine of x plus h, the other there. So let's do that first for it. Sine of x plus h over h minus the sine of x over h. Let's just do that for now and see what we get. How would you expand sine of x plus h? Sine of x plus h. What would that be? Sine x, say again, cosine h, yeah. Plus, say again, cosine x, sine h. Is that what I'm hearing? Okay, I thought so. Okay, all over h minus sine x over h. Okay? We've expanded that now. So I'm going to do this a little bizarrely because I just don't have that much room to write. What I'm going to do is split this into 2 fractions. Okay? Both over h. This over h and that over h. So everything's over h, right? Now, what I want to do next is get my sine x's together and the cosine x's together. Okay? Because that's what we got up there. Well, already this term right here is exactly that one. That is, this thing here is cosine x times sine h over h. That's exactly what this is. Okay? Now, recombining these two, let's factor out a sine x. Okay? And we'll say plus a sine x. That's taking a sine x out of both of those. And what are you left with? A cosine h minus 1 over h. And that's exactly what this is. Sine x times cosine. Whoops. Okay. Not exactly what it is. If they reverse these two, you'll change the sign. So that would become cosine x times sine h over h minus sine x times 1 minus cosine h over h. Now it looks just like that. So that wasn't too bad at all. Does anyone know where we'll actually use something like this in calculus? You don't have to know. I'm just wondering if you do. That's going to be the definition of a derivative. That's exactly what it is. If you take the difference of two functions as your x changes a little bit, what's the difference between sine, okay, here's your x, and over here's your x plus h. H is that little difference there. So the sine of x plus h minus sine of x, that's the difference in y values over x plus h minus x, that would be here. That's your slope formula, okay, which is your first derivative. As you let h get closer and closer to 0, rather than being the slope of the secant line, that's approaching the slope of the tangent line. And that's exactly what your first derivative is. But you don't need to know that yet. All right. Then they have a checkpoint. You do the same thing with cosine x plus h minus cosine x and see what that turns out to be. All right. Well, that's how I did it. Let's see how they did it. Oh, wait, we'd already done this. Sorry about that. They didn't do it. That was example 8 wasn't given. All right. Let's do vocabulary. Top of page 379, 5.4 vocabulary. Fill in the blank. Sine of u minus v is? Right? Minus cosine u sine v. Perfect. Number 2, cosine of u plus v. Say it again.
Is it sine first or cosine first?
Cosine first.
Cosine u
Cosine v minus sine u sine v. That one, it matters which one you go first because of that minus sign. What's tangent of u plus v? Okay, tangent u plus tangent v over 1 minus tangent u times tangent v. Good. Number 4, the sine of u plus v. Yes, sine u cosine v plus cosine u sine v. Perfect. Number 5, cosine of u minus v. Yes, plus sine u sine v. Perfect. And tangent of u minus v. Perfect. Okay. Homework exercises here, then do either 7 or 9 or both. They've got 2 parts each. One of them's in radians, one of them in degrees. I would say do both, okay? Then do any of the odds 11 through 25. Some of those are in radians, some are in degrees. I do some of each. Then do any of the odds 27 to 33. Any of the odds 35 to 39. And they have one of those in degrees, the others in radians. I would do one of each at least. Then do any of the odds 41 to 45. Okay, 45 is a lot different. Oh, it's just, yeah, but it's given for us two specific cases, okay? And then do any of the odds 47 to 51. And then do either 53 or 55 or both. We did one like that in class. Then do any of the odds 57 through 63. Do either 65 or 67 or both. We did some similar to that. Then do any of the odds 69 to 73. And either 75 or 77 or both. Okay? Do 79. Okay? Then look at either 81 or 83, true, false. You won't see many of those on test, but certainly something worth thinking through. 85 is another one worth plowing through. 87 and or 89 are probably worth looking at. 91 or 93 are at least worth thinking through. And do 95, do 97, do 99, and you can look at 101 if you'd like. It's a fairly tedious type thing to do. Take a look at it. I think you can find that proof maybe at the end of the chapter. So one section off. Okay, I thought, let's see, yeah. We don't have much time. So let me end this. And if we can get the new one up in 1 minute, let's see what we can do. It's just a real neat picture on front, and I don't know if that picture's still on the slide. Yeah, it should be. Okay. Yeah, I don't think we're going to have time to do anything on it. Well, what we're going to do next, this is just a little preview, multiple angle and product to sum formulas. Now, not only product to sum, we'll also do sum to product formulas. The multiple angle formulas, you really do use a lot, okay? And those we'll do first. The product to sum, you use very occasionally. So whether it's worth memorizing or not, I don't think. But it is worth being familiar with. So we will do that, and we'll start with our objectives next time, okay? So we'll basically just introduce this one. We will do the objectives next time. Okay, 5.5 is the last section we're going to do. It's the last section in the chapter. If we finish this on Thursday, I'll give you your take-home test on Chapter 5. Even if we don't finish it, I'll give you the option of taking the chapter test if you want to, so you can start working on the first part of it. You may not be able to work the last problem or two. I think you probably would be able to, but you couldn't do it. So I'll try to have your test ready for you on Thursday, and that way you won't waste your Veterans Day weekend with nothing to do. Yes, you'll have some good old trig to work on. That'll be fantastic on it. Good deal. Okay. All right, good deal. We will see you on Thursday then. What's that? Yeah, we will have a final. It'll be take home also. It'll be a take home also. And it may actually be in two parts. Maybe you'll have the first part on the Chapter 6 test, and the second part will be the final. It will be comprehensive. They'll both be much shorter than the other test of it.
Cool.
All right. We have a couple people who haven't been here in quite a while.
The physics class is next semester.
Okay, say that again.
The physics class is next semester. I looked online, all I needed is the first part of physics.
You're going what?
All I needed is the first part of physics, like chemistry, teaching.
Okay. All right, let me explain that. I always set it up for me to teach the 201 and 202, Dr. Bryant to teach the 213 and 214. In the summer, we almost always teach them separately because we have lots of tangents going on. But in fall and spring, we almost never have enough students to teach them separately. So we stack the classes 213. Physics is the same, the math level is a little different, that's all. And we'll stack 202 and 214 unless we have enough students in both classes to make it. We seldom do, thank you. So, the odds are it's going to be Dr. Bryant.
Okay, but it is going to be a physics class this semester.
Yes.
201.
Yes.
So,
And it'll be approximately those times. We may fiddle with the times a little bit because his times and my times don't quite line up together. But when we stack them, we'll fix it so they'll line up well.